Welcome back, everybody. Here goes another video on graphing rational functions, but this time we're going to have higher degrees. So it's not going to just be like 2x plus 1 over x minus 3. Now we're going to have higher degree exponents in the numerator or the denominator or both. So let's talk about what that does in terms of your asymptotes. Well, it actually does nothing to your vertical asymptote. As I mentioned in the last video, your vertical asymptote is always going to be what makes the denominator 0. But when you have higher degrees in the numerator versus the denominator, and vice versa, or same numbers, that's going to change things up a little bit. So if your numerator has a higher degree, you're actually going to have no horizontal asymptote. And what that would look like is something like x squared over x plus 2. So we know that this is x to the first power. So the top is a second degree, the bottom is a first degree or linear. So this means we have higher exponents in the numerator, which means we have no horizontal asymptote. In the second possibility, we have the same degree in the numerator and denominator. So example, 2x squared over 3x squared. Your horizontal asymptote would be 2/3, and that's very similar to the last video when you just take the leading coefficients and write them as a fraction. And the last option is when you have a higher degree in the denominator. So similar to the first one, we just flipped it. Now we have x plus 2 linear over a quadratic x squared. When that happens and you have more x's or a higher degree in the denominator, your horizontal asymptote will always be y equals 0. Okay, now these graphs are going to be a lot more complicated than the ones we did the other day. These are going to be more than just hyperbolas. So there's actually a couple that are not even close to being a hyperbola. So we're just going to go show you how these look like on a graph. Again, you do not have to graph these by hand. You can just use your graphing calculator to do this. I will tell you what you need to type in there, and you just have to go do it. So let's talk about our vertical asymptotes. First thing you want to make sure is nothing can be factored. You cannot factor the sum of squares. So our vertical asymptote is, we don't have one. Here's why there's no vertical asymptote. If you set that equal to 0, so x squared plus 1 equals 0, we get x squared is equal to a negative 1, so x is equal to plus or minus I. Well, we can't have an imaginary asymptote, so we actually have none. Our horizontal asymptote, you have to follow the chart. There is a higher degree in the denominator, or more x's in the denominator. That means it will be y equals 0. So the first thing you're going to want to do is horizontal line dashed to represent that's a horizontal asymptote. And then what you want to do is just go type that in the graphing calculator. So as we talked about in the last video, it's y equals, you have your numerator, 4, divided by your denominator, x squared plus 1. Numerator and denominator must be wrapped in parentheses. So then you type that in the graphing calculator, and you're going to get something that looks a little bit like this. Again, you would just go to the table, get a few good points, but your graph is going to look like this. Okay, so I told you they're not going to be hyperbolas all the time anymore, but that's because we're changing with the exponents and stuff like that. That's only when it's like 2x plus 5 over 3x plus 6 or some of the other ones, okay? We can create hyperbolas, but now these are going to be a little bit different. Again, just like I mentioned before, being able to identify this information and sketching that's the most important part. But as far as graphing, just type it in the graphing calculator. Another example, this is an example where we have the same degree in the numerator and the denominator. So, of course, you want to factor this first. This is factorable, so we have x plus 2 and x minus 2. So, red flag, you have to set each of those equal to 0. So your vertical asymptotes are going to be x equals a negative 2 and x equals a positive 2. Do not write x equals negative 2 comma 2 because these are lines. This is one line and this is your other line. So make sure you are not just writing x is equal to negative 2 comma 2. So I would go sketch those really quick. Just kind of give that part a little sketch. And here's your other one. Give that a little sketch. Next part, we have our horizontal asymptote. Since we have the same degree, we have 3x squared over x squared, so that would be 3 over 1. So our horizontal asymptote is y equals 3. So we would go sketch a horizontal asymptote right here at x equals 3. Again, type it in the graphing calculator the same way we mentioned last time. Just wrap the numerator in its own parentheses, the denominator in its own parentheses, and you will have an even crazier graph this time, which we have an upside down parabola in the middle. And then we have two other sets of branches on the outside. So we actually have 3 sections here, and here's why. We have 2 vertical asymptotes. And remember, vertical asymptotes represent parts of x's that are never allowed to happen. So we're never allowed to touch this line. We are never allowed to touch that line. So therefore, we have a 3-part graph because of the 2 vertical asymptotes split this into 3 parts. Okay? Our last example is going to cover the last option, and this is when you have more x's in the numerator. So if we have more x's on top, that means we're going to have no horizontal asymptote. And our vertical asymptote is still going to be x is equal to a negative 2. So we're going to have something that looks like this, but no horizontal asymptote to worry about. So go type that in your calculator and see if you can come back and see if you can match the sketch with mine. Give it a shot. And if you got that, you're good to go. So again, make sure you have the top and the denominator wrapped in parentheses when you type it in your graphing calculator. And this time you had no horizontal asymptote to follow, but you did have to make sure you never reached this vertical asymptote of negative 2. Now, this is an example of something that actually has an oblique asymptote. Don't worry about that. That's a calc or pre-calc level question where you have to find oblique asymptotes. So we're not going to worry about that here. I just wanted to show you that someday you'll know how to work with that as well. Okay, so that's it for this video on rational functions at a higher degree. This is Longo and I'm out. See you, bye.